Now, how you can determine the absolute configuration of this molecule? For this, you first of all have to determine which group has the highest priority. So, which one is the major group, which has the lowest priority, which one is junior group, and which groups are in the middle. For the determination of these, you need first of all determine which is your first atom. If you have monoatomic substitution, so directly its atomic number you can use for determination of priority. But what about the OH group? In OH group, your first atom, which is bonded with this chiral carbon, is directly this oxygen. So that's why you have to take oxygen's atomic number, not H atom's atomic number. Now look, which one has the highest atomic number?
Cl.
Yeah. So this is number one. Remember, please, number one always is the group which has the highest priority. So this one is number 4. It's junior group. Number 4 is the lowest priority group which has the lowest priority. Now between them, this one, number 3. Oh, sorry, number 2.
Excuse me, no.
And this is number 3.
CL.
Where is CL? This is CH.
CL not found.
Oh, sorry.
صدق والله.
After that, once again,
Why the OH is number 2 is not
number 2. This one. So I write for it, then I change. Sorry. Number 2, number 3, number 4. After that, write these priority numbers directly on this with these groups. So this is number 1. This is number 2.
Why the OH?
This is number 3, and this one is number 4. Once again, oxygen's atomic number 8, that is why OH group is number 3. And fluorine's atomic number is 9, that's why this one is number 2. Now look, don't look at the first time on the group which has the lowest priority. Don't look at this. 1, 2, 3. So, priority decreases anticlockwise. Yeah? Anticlockwise. So, after that, anticlockwise. After that, look at your lowest priority group. If your lowest priority group on the vertical line, so in this case, you have to change absolute configuration. So without this, if your priority decreases anticlockwise, it means that you have S absolute configuration. But because of your lowest group on the vertical line, so you have to change S to R. And finally, your molecule has R absolute configuration. So this one is R. Now, if you have this version,
هذا الاس عكس العقارب الساعة والار وعقارب الساعة.
okay, if you have this version,
So what it means is and
once again, you have to use Gunn-Prelog-Ingalls system for determination, absolute configuration of your molecule. For this, first of all, you have to deduce which one has higher priority, which one has lower priority according to their atomic numbers. And please look at the first atom. If you have only monoatomic substituent, so you can use directly its atomic number for determination its priority. If you have polyatomic functional group or substituent like OH, so in this case, look at the first atom. Its first atom in this case O, and oxygen's atomic number is 8, so its own priority number has to be 3. Because of fluorine has atomic number 9. After that, write their priority numbers directly on these groups. And don't look at the group which has the lowest priority. Determine you have R or S. If your priority decreases anti-clockwise, like in this case, so the absolute configuration has to be S. But because of your lowest group on the vertical line, so you have to change this S configuration into R. So finally, this molecule has R absolute configuration. This one has R absolute configuration. Now, I don't need this. Let's discuss about this version. About this version.
This is
So, once again, this is number 1, this is number 2, this is number 3, and this is number 4. Yeah?
no. This is 4 and this.
Oh, sorry. This is number
3, 4.
this is number 4, and this is number 3. Yeah. Now look. Don't look at this. 1, 2, 3.
Hey there.
So your priority decreases clockwise. So this one have to be R. This one have to be R. And because of your lowest group on the vertical line, you don't change. You will not change this absolute configuration. So R stays as R. So this one has R absolute configuration.
ايوه بعد بتغير لو تغير كان صارت اس.
You understand or not?
Yes, I understand.
Really?
Yeah, but
No,
ask him
Can you repeat with a new example?
just about
Yes.
S and R. They stay together.
R
شوف لا.
into R. Why? Because of your
عمودي هذا
group
عمودي.
with the lowest priority on the vertical line.
إذا مستقيم.
In this case, you will change your
To S.
absolute configuration. R stays as R. In this case, your lowest group on the vertical line. That's why I change S
To
into R.
محمد ما تقول
أفقي.
هذا من عمودي R.
لا هي قالت عمودي.
Now let's discuss about the other.
لا أفقي لا أفقي.
Another example.
Yes, another.
Another example. Now,
قيمته أقل الاتش إذا بالأفقي
أقول لك ليش؟
يتغير الناس. وإذا
ليش انت تدور محدد تدور نجاح؟
if you have
لك لا
4
تلعب.
examples, this one, CH3,
صح صدق
لا هاي
and
روبا.
Cl. So our substituents are CH3,
CH3.
OH.
then OH, then Cl, and so which one has the lowest priority? Which is number 4? This is number 4. This is
Yeah,
G.
number 1.
Which is number 1?
No,
Cl is number 1. Now what about these two groups? Which one is the first atom
Eight.
which is
Oh.
bonded to this chiral
This
carbon?
one is H.
Here.
Oh.
Oh.
You have to see this
Which
table.
atomic number is 8. So this one has to be number 2. Now here, which atom is the first atom which is bonded? Carbon. And carbon's atomic number is 6. So that's why this one is number 3. Now
عليك
let's write
بالعنصر
بالبداية.
four,
ما تجمع وايد
لا تاخذ.
one,
بالعكس أقرب الساعة ولا ويا
three,
الساعة؟
and 2.
Madam,
هذا
Yes.
رقم واحد.
why you written here this one OH it's 2? It has to be here. Because this one is 6 carbon.
And 8.
Because of first
That
atom
one is
in this
six,
6
and this one is 8.
8. So
Yes.
this one is number 8.
شلون نعرف الثلاثة
This one
والأربعة؟
is number 3.
جدول.
That's why. Because of oxygen's atomic number is higher than carbon's atomic number. That is why OH group goes as number 2 and CH3
From
as...
high to down.
Yes, yes. Now look. Don't look at this. Only this.
Yes.
1, 2, 3. So it's clockwise or anti-clockwise? Anti-clockwise. So absolute configuration has to be S. Then look at the lowest group. This one on the vertical line. What it means? So S stays S. So finally, your absolute configuration for this molecule
لو أفقي كان
is
صار.
S. Now if you have this version,
يقضي السبورة صار عمودي.
كان في عقارب الساعة الثلاثة.
ايه
So this is number 4. This is number 1.
ما له عقارب الساعة هذا هو عمود.
الحس الأول عن عقارب الساعة.
Don't look at things. 1, 2, 3.
عمود وفوق.
على العمود.
What is this?
This is
S goes like
S.
S.
no, but the color changed to R.
Yes. Why? Because of your lowest group, all the vertical lines. So finally, we get R. So as you look, as you see these molecules, these two structures, you can determine they are enantiomers or not of each other, because
Yes,
they are mirror imaging of each other. Yeah.
Yes.
But really, they are enantiomers. Remember, please, if you have enantiomers, if one has S absolute configuration, second always has R absolute configuration. What it means? If here you have S, and if here you have R, and if you have same substituent, so that means that these two molecules are enantiomers of each other. Are enantiomers of each other. It's easy when you see when they are mirror imaging of each other. It's easy to determine they are enantiomers or not. But if you have this version here, you have to determine you have absolute configuration of this molecule. If you have S and R, so they are enantiomers of each other.
S are enantiomers.
So now let's discuss about more complex substituents.
So and how it will be the question?
I
بس اللي شو ما
فهمت بس يعني كسؤال.
جاوب بالسؤال.
شلون؟
أقول لك
Guys,
شلون ما كان بس
please don't ask me how it was. I don't know really.
Yeah, but how we can study like this?
You understand?
Yeah, I
If you
understand.
study, you understand that.
I understand, but I don't know how to
زي
do
بس
the
ساعة
question.
الصبح.
How I can
Now,
answer?
if you have
عشان أجاوب.
كنت أرقم عليه نسكت.
CH2, CH3, C, CH3, 3 times,
هيك تجيك.
and H.
نفس الشيء شيء يعني.
If you have this one, now let's discuss about this. Which substituents we have?
كلهم
H,
كربون.
CH3,
No, 2. Ah, yes.
CH3,
Yes.
and CH2,
أنت لو
CH3, and
سي.
CH3, 3 times. Do you remember the name of this one? Tertiary butyl. Now, what about this? Of course, H has the lowest
Low.
right. It's very
Number
easy,
4.
yeah? But
That's
what
it.
about these two structures, these three structures? As you see,
Let
in
me see.
all three
Carbon, they have carbon.
Starting with
substituents, the
carbon.
first item is
Carbon.
carbon.
كربون.
After that, please
Last
look
one is
at
I.
the next atom. If in next atom you have different substituents, so you can determine which has the higher priority, which one has lower priority.
أنا شفت
Now what
الصبح.
about this carbon? What is the substituent? H. In this case, you have 3 H.
So it will be number 4.
So H. Now what about this carbon?
5.
H,
Two
H,
H.
and C.
أربعة.
Next one is carbon, yeah?
يلا.
So H, H, and C. Do you understand why?
Yes, yes.
Because of this carbon has 2 H atoms, and then goes carbon. Second carbon. Here you have 3 H atoms, H, H, H. Here you have H, H, and then where you have difference in this carbon atom. Now what about this
3
carbon?
C.
C, C, C.
3 carbon.
Because of after this carbon, you have 3 carbon CH3 groups.
Higher.
So, C, C, C. So, which one is number 2?
This
C.
one.
This one is number 2.
ليش؟
And this one is
This one is number 3.
سي. طيب سي
And
سي.
this one
C.
is
Double H C.
number...
هذا اتش اتش
Wow, just a moment.
No, this one.
This
خلاص
one.
أنا شفتها.
One,
2, 3.
2, and this one is
السيات
number 3.
بهواية واحد
إيه.
على كل ما قل السيات كل ما يزيد العدد.
Yes.
Yeah.
You got it or not?
Yes.
After that, write these numbers on this group. groups.
ليش ناخذ بس
So,
ثلاثة؟
4,
كل ما تقل شو اسمه
this is number
3
3,
واحد
this is number 2,
كل ما
and this is
تقدم
number 1.
الاتشات
Don't look at this.
مو كل ما يعلى
From S to R.
عليه شات عقيل.
تقدر تقول
Anti-clockwise.
شلون
شات مضبوط.
So,
هذا بنساوي
that
نفس
will be
الشيء.
S. After that,
هذا
look
شنو؟
at this.
ديفرنشيال
So-
بالشكل يعني.
On the horizontal line, so you have to change this configuration. S into R. So finally,
بعدين
you have R configuration.
أفقين.
Finally, you have R configuration. Now remember please, if you have, now another question. If you have in the substituent double bond or triple bond, what you have to do? For example, if you have this structure,
اللي معود
if you have this structure,
سهل يجيك شيء. عقيل
so aldehyde group, carboxyl group,
محمد.
SH, thiol, and methyl group. What about this one? Here, you have SH, CH3, COH, and COOH. Which one is number 1?
This one?
Number 1.
كاربوكسي
No, this one.
S.
Why?
صح هذا
ليس.
What do you see here?
How much?
S atomic number is 16.
16.
Carbon's atomic number is 6.
6. Yes.
So this one has highest. This is the major group. So this number 1. Now let's
this is-
start
this
about
four.
this structure.
This CH4, CH34.
Here you have H. In any case,
Yeah, this
this one goes as the lowest priority group. So this one always is number 4. Now what about these two structures?
This one second. COOH.
And this one
Yeah,
number
yeah.
7. Let's explain why. If you see double bond, if you see double bond, duplicate this atom to which carbon is bonded by double bond. If you see triple bond, triplicate this. Here you have double bond with oxygen. So for this carbon atom, substituents are O, and H. Now what about this one? O, and O. So
No, this-
which is number 2?
Third, last one.
This one is number 3. This one is number 3. Why? Because of oxygen's atomic number is higher than H atom's atomic number. That's why. So let's write 1,
خربط بيها ترى.
4.
لا ليش؟
This is 3 and 2.
قاعد جنبه.
Don't look at this.
Yes, don't.
Because of in this case, this one is yellow.
No, opposite.
One.
Opposite,
one,
opposite.
two. Anti-clockwise. So it has to be
S.
S. And
But it
then
will change
you
to
can
R.
change this one into
Yeah.
R. Why? Because of the lowest group on the vertical line. So if you use these rules, you can determine you have R configuration compound or S configuration compound. It's Kahn-Ingold product system.
اللي هو أعلى من ال H.
No. If you have, for example,
هاي أعلى بها أوات
تصفط أميكي.
اكيد مالي هذاك واحد.
هاي أو جورج شنو هيك؟ هاي جورج شنو؟ تمسك هاي اختلف بيناتهم. تمسح هذا كله شابي؟
هاي حافظها بس أدري على الترتيب
لا
مال
ما
أوات.
تحفظ. لا كلش تحفظ منها.
يعني مفتهمها قصدي. هاي شنو هاي دبل عصرة تربل عصرة.
سيج.
Yes, we will repeat this.
first of all,
We need this one. This
And number 1.
Periodic.
then COOH, then
لازم تطلع.
CH2Cl, and then CH3 three times. Now, if you
Open.
use triple bond, it
Three.
means that you have to triplicate this.
Yes.
So here you have
And.
and. What about this one?
Oh,
What about this one?
HCl.
HCl. And what about this one? C. What will be
Just the number for
So this is to be
nitrogen's atomic number is 7. Oxygen's is 8.
21. And this one is
Now, once again.
so it will be
this one and
أخذت تشرح أخذت تفك حلقة.
This one has the lowest priority. Yeah, because of you have here carbon.
This is 4.
So this is number 4. Now what about number 1?
it is N.
Yes. This one is not.
No, this is number 2.
Just.
Number
يعني
number 3.
كل ما تكون من جدول العدد
If you see,
لا أغلب
you have to find first difference. You have to find first difference. Now, if you see, is a molecule.
كله رقم مكتوب العدد.
This one is wrong. Just listen.
The second one.
هاي probability. هاي
Which
probability.
one?
The second one.
ما عندي جدول.
This?
Yeah, it will be OH.
Oh. Because
Wow.
of weak carbonyl group, you have double bond with oxygenation. That's why. Now listen to me. If you see Cl,
ما يكتب.
in any case, this
هل
is
الشوكات
higher
بتسوي؟
priority than these two groups.
لا والله.
Because of Cl's atomic number 17. Yes, with Cl you have H.
هاي لك هاي ست أوقات.
Because of Cl has atomic number 17. This one has the highest priority. So this is number 1. Now what about this?
ما أدري أشوفها.
This is number 2, and this one is number
ربنا
3.
يصعبه.
And after that, once
القسم
again, you can determine you have R or S. So this is number 4. This is number 1. Once again, because of here you have
إذا
Cl.
كان بيعاصر شو اسمه منفرد.
2, and this one is number 3.
يعني أنت تقصد
And
على
after that,
أكسجين.
anticlockwise.
الرسم لا.
وأنا مو سي دبل أو اتش حبيبي. مو سي دبل أو اتش.
S has S.
الأس ما تأخذ.
Why? Because of this one.
تأخذ غني بس ليش ما
بس
تأخذ؟
هاي
So, this is how you can use Kant parallel ingot systems for determination of
H.
higher
بس
priorities.
ترسل سي أو أو إس.
الأكسجين إيش قال؟
واي أو أو.
If you see double bond, duplicate this.
and OH.
Oh.
والاسم ما أخذنا.
Please always look at the first atom, which is mounted with your card. Now, what about another type of stereoisomers? Geometric stereoisomers. What is geometric stereoisomers? Cis trans. If you have
4 إلى 10 يمكن مو؟
if you have this molecule,
وش
CH3, CH, double bond, CH, CH3. Alkene, remember please, about geometric isomers, you can discuss only in alkenes or in molecules where you have double bond. Why? Because of alkenes are planar molecules, because of carbons are in sp2 hybrid state, and if these two carbon atoms, which are in the double bond, have at least one pair of same substituents. So in this case, you can discuss about cis trans isomerism or about geometric isomers. Now look, I can draw two versions of this molecule. First one is this. And second one is this. So these two molecules are isomers of each other. So this is an example of geometric isomers. Now look, once again, for discussion about geometric isomers, you need at least one pair of same substituents which are bonded to the carbons which are in the double bond. So in this case, you have two pairs. It's H and CH3, CH3. Now remember, If same groups are on the one side of your plane of double bond, in this case, you have cis isomers. If they are on the opposite side,
Trans.
so you have trans.
Trans.
So the full name of this one, if you have this structure, is cis but 2E. And the name of this one is trans
Trans.
but
وينات بشرح
2E. Now, if you have this molecule group, CH2, CH, CH2, CH3, can I discuss here about geometric isomers or not?
Yes.
No.
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 Because
If you have one butene or but1,
we can't.
Yes.
There must be two.
yes. Why? Because of this carbon has two same substituents. And it does not matter which one is up and which one is down. That's why. But if you have this Cl here,
Also no.
well, in this case, you can discuss about cis trans isomers.
Oh.
Now, fine, please. Now let's open
Hey.
this molecules. Okay? Let's open. Let's open. Carbons which are in the double bond. Let's write separately or substituents. C double bond C. Then you have this part. CH2, CH3. Now, first carbon has H, CH. Second one has H, and then goes this part. Yeah? Have you here with two carbons, two same substituents?
No.
Yes. Do it.
Yes.
Ah, yes, yes.
This, I think.
So I can discuss about cis trans or geometric isomers here. Now look, if I draw this version, this is cis.
Cis.
But if I draw like this,
Cis buta. Butene.
H, C,
Good. إيه.
then
Butene.
CH2, CH3, H. So as you see, these two same groups are on the opposite side of the plane of your double bond. So this one is trans isomer. So this one is cis one.
And what about this chloro? If we
About full name.
yes,
About full name. Now what about full name? In this case, because of your same groups are on the opposite side, so this one is trans 1 chloro but 1 ene.
Please, right.
Trans 1
انتقل
chloro but 1 ene. Yes?
Trans.
And this
Trans
one,
1 chloro.
yes, in this case, you have to change trans into cis. That's all. Cis 1 chloro but 1 ene.
Trans 1.
Without chlorinator, but 1 ene has not geometric isomers. Why? Because of you, in this case, you have same groups with first carbon, 2H atom. So, if you see same groups separately on the both sides of this double bonds, in this case, you can discuss about cis trans isomers.
So every carbon must have two attached to it.
Like each
At least one same group. So I write one version and tell me please, have you here? Cis trans isomers or not?
لا ترانسز.
So
Now, for the